Hello, in this production tip we're going to talk about how to measure and consider what's called the dough to pan ratio. So what we see here on the table in front of us, we have a bread pan, we have a cupcake or muffin pan, we also have a calculator, we have a little ounce or gram scale, and then we have a little ruler here with inches and centimeters. And that's really all we need to do to illustrate this concept. So what I'm going to do first of all is I'm going to turn my scale on, and we're going to measure how much this bread weighs. I want to do everything in grams as opposed to ounces, and I'll explain a little bit better later why that's so. But in summary, really, is we know the grams and the centimeters are smaller units, really easy to measure. So this is actually a loaf of bread that's been frozen, because to measure it, it's actually better if it's frozen. It's a little bit less crumbs on the table. It's already starting to thaw a bit. But what I want to do is tear my scale, make sure it starts at 0, even though you may not be able to see it. I know I can. But just the concept, we tear the scale, we put the loaf on there, and hope it doesn't tip. This looks like 476 grams, so I'm going to write that down so we know what the bread weighs. Okay? And then what we're going to do after that is we're actually going to measure the bread. And so what we're going to do is get the volume of the bread. Of course, it's probably collapsed a bit since it was baked, I'm guessing. Plus, I took it out of my freezer, so it might have been a little smashed in the freezer. But that's really not going to matter, and I'll explain why in a minute. This is our scale. This is centimeters, and this is inches. I prefer to use centimeters because it's easier to communicate with people around the world, and plus there's more centimeters than there are inches, so it's a little more easier to measure, I believe. So what I'm going to do is take this loaf of bread here, try to hold it together as best I can, and then I'm going to measure right in the middle of the loaf what the length is. Looks like the length is about, I did this before we started running the video, so between 27 and 28. When I did it earlier, I actually had it with 28, so we'll just go with the 28, that's fine. And then on the width, probably the easiest thing is just take any particular slice. I'll just take the heel here. And I'm going to measure just from side to side in the middle of the heel. Looks like about, well, this is centimeters now. Looks like if I put my finger right where it is, about 10 centimeters. So we have 28 centimeters long and 10 centimeters wide. And then the height of the pan is somewhat open to interpretation, because looking at this, where did the pan come up to? I'm going to guess it's going to be about to here. So measuring the height of the pan, I'm going to go from about where I'm guessing to the bottom. Looks like about 7 inches. So I'm going to use 7 inches for my depth of the pan. Just sort of guessing here because I don't have the pan in front of me. So if I multiply those numbers together, 28 on the calculator here, 28 centimeters by, what was the width again? 10 centimeters. Times 7 centimeters, I'm sorry, not meters. So we have 28 times 10 times 7 centimeters gives us 1,960 cubic centimeters. If we take that cubic centimeters and divide by the weight of the product, which was, I wrote down, it was 476, that's equal to 4.117, so it's just a little bit over 4. So basically what we have in this loaf of bread, we have 4 cubic centimeters, or cc's, per gram of baked weight. Okay, this is baked weight now. But I'm actually going to be more concerned in the production side with raw weight. So what I'm going to do is I'm going to make a separate calculation. I'm going to say that if this finished weight was, as we just measured, 476, I'm going to assume about a 15% total process loss from raw weight until finished packaging like we have here. So if I take the 476 grams and I divide it by 0.85, that's my guesstimate of what the raw scaling weight was. So I'm saying to get this 476 gram finished loaf of bread, most likely our raw weight would be around 560. So if I use the 560 number, instead of the 476, I'll get a little different answer. So if I take the total volume of the pan, 1960, and divided by what we just calculated, oops, hit the wrong one here, it was 560. 1960 divided by 560, that gives me a 3.5. So I'm guessing this was actually 3.5 cc's of pan per gram of raw dough. So I'm going to write that down. Now, why would we care about that number? Well, what we can do in really any kind of bakery product, this is just bread though, we're examining how fine is our grain. Because generally speaking, the smaller that number is, the more dense my grain is going to be. Because if I have less cc's per gram, means I have less space in the same weight, or I have more weight in the same space. So the more raw dough weight I put in the same pan, it's going to have to expand less. So this is something you might want to benchmark with your product versus perhaps the competitor. So this is a pretty dense grain. It's also, in my opinion, or what I've seen in the industry, this number is actually going down with the years I've been in the industry. Because as we take more and more chemicals out of our products, we really have to put a little bit lower ratio of dough, because we can't have the dough expand quite as much. So this is a ratio of about 3.5 cc's of pan space to grams of raw dough. So I'm going to just use that as a benchmark and get that out of my way for now. Then we'll move on into measuring the pans we have before us. So this is a bread pan, obviously, fairly new and pretty good shape. So what I can do is, you might notice by looking at the pan, that the pan has less length and width on the bottom than it does on the top. That's why you notice when I measure the bread, I measure the middle of the bread to get an average. So in this case, I can measure, I'm interested in the volume inside these four walls, if you would, plus the bottom. So what I'm going to do is make sure I have my inches on this side and my centimeters on that side. I'll start with this and measure from the inside of the pan on the top how many centimeters do we have. Looks like I have about 11.5 centimeters width on the inside along the top. Now I'm going to write that down over here. Looks like 11.5. And then what I'm going to do is hard to demonstrate this, but I'm actually going to try to eyeball it. And I'm looking straight down. I'm looking at the very bottom of the pan on the width, and it starts there at 0. It looks like it's about 8.5. So it's 8.5 centimeters from this bottom side to that bottom side. I'll write that down, 8.5. And so if I use my calculator and I take 11.5 plus 8.5 divided by 2, I get an average of 10 centimeters. So the average width here is 10 centimeters, which incidentally enough was the same as our bread that we measured, but it's not the same pan, I guarantee you. It's just a coincidence. And then we'll also look at the length. So in this case, I put the length up here. Looks to me like 22 inches from the top to the top. I'll write that down, 22 inches. And then I'm going to try to eyeball it on the bottom. If I'm really careful here, looks like about 18.5 if I look bottom to bottom, which is here to here. We'll write that down. And so if I do the math, 22 plus 18.5, I don't trust my head, so I'm going to do the calculator. Divided by 2, my average is 20.25. That's the average. That's the average length that would be essentially the length from the center to the center, if we just use the law of averages. Then I can measure the height of it, or the depth, I should say, and that looks like it's going to be about, so I get this right, 6.5, I believe. I think that's right. Actually, I got to look at that again. I measured it earlier when I was not on camera. It was really closer to 7. Okay, so we'll say 7 centimeters. So what I can do, I've measured, so now what I have is the average depth, which is the same number, an average length, and an average width. So let's use the calculator and figure out what my cc's happen to be. So I have an average of 10 centimeters for a width times 20.25 centimeters for a length times a depth of 7 centimeters. That gives me 1,417.5 cubic centimeters. That's what's in this volume, okay? So now if I take that same number, which is cc's, and divided by cc's per gram, I get how many grams of raw weight dough I should put in here. So take the same number, divided by the 3.5 we calculated earlier, and this should be 405 grams of raw dough in this pan to get the type of bread with more or less the same grain structure as the one we use as our measure. So I think it's kind of interesting because in my career I've seen anywhere from 3.5 cc's per gram up to about 5 cc's per gram. The 5 cc per gram would be a very expanded loaf. It would actually be a way to maybe reduce my cost if I could get more volume with the same weight or less weight in the same volume. But so based on what my benchmarking, I'd just calculate I want 405 grams. I'd probably use 400 grams of raw dough in this pan to get a halfway decent loaf of bread if I do everything else right in my process. So that's how to determine, or one way to determine your desired target weight as far as raw weight per pan. Of course, in real life we have to be concerned with our label weights, but this is more of an R&D exercise, or maybe if you're just trying baking in a new environment, perhaps. It's great for classes that I do, for instance. I also have a cupcake pan here, a muffin pan, and what we can do is sort of the similar idea. I really didn't bring any muffins or cupcakes to benchmark, but I'm just going to go ahead and show you how to measure a round pan. So in this case I have what's called a diameter because it's obviously circular. So if I hold this up, I don't know if the camera can catch this very well, looks like about a 7 centimeter diameter. My inches are on that side. So I want to keep with centimeters, so 7 centimeter diameter. I'm going to write that down. And so we've got that for 7 centimeters. And then, the other thing I forgot to tell you, that's just the top. The 7 centimeters the top. Remember, we have to have an average. So I have to sort of eyeball the diameter on the bottom because it's a smaller number. Looks to me like it's about maybe 4 3/4. 4 3/4. Yeah, that's right. So if I make an average here, what's the average diameter? I have 7 centimeters plus 4 3/4 divided by 2. My average is 5.875 centimeters is my average diameter. So let me go ahead and save that if I can do this properly. Let's clear this first. Okay, so I had the let's do that again real quickly. It's 7 plus 4.75 divided by 2. Here's my average. I'm going to put that in my memory. Not my memory, I don't trust a memory, the calculator. So that's my average diameter, which I'm going to need for my calculation. Then I'm going to have to try to guess my depth. Shouldn't guess, I'm measuring the depth. Looks like 3.5. And so if you weren't sleeping in class, we talked about how to calculate the area and the volume, or the area of a circle, for instance. We know it's pi r squared, believe it or not. Still remember that. So if I take what I had in memory here, which is the 5.875, that's the diameter. So to get the radius, I simply divide it by 2. So there's r, or radius, times pi. I'm kind of lazy, I'll just go 3.14. So that's my, and I also have to do my radius again. Let me start over again. I did that. I got too much of a hurry. So here's my diameter. Divided by 2 is my radius. Remember the formula is r squared. So if my radius is 2.9375, I got to multiply that again by itself. Times 2.9375. There's the area of the circle. Average. I got to multiply that by the depth, which was, I wrote it down, looks like 3.5 times 3.5. And I get 10.28. That doesn't sound right. Let's do it right. Do it again. Here's my, okay, there's my diameter. Divided by 2 is radius. Times the same thing, 2.9375. There's my area. Times 3.5 depth. So I've got 30. Get that right? What did I do wrong here? I did it earlier and it worked. Oh, I forgot to multiply by pi. That was a problem. No wonder. So if I take the 30 times pi, okay, we left out the pi. I will have no pi, I guess. So it comes out to be 94 point something. So that's my cubic centimeter. So we're saying that the area, or I should say the volume in this cupcake tin or cup is actually 94 point something. We'll say it's 95 cc's. Now, when I make cakes or muffins, I can't use that same factor that I would use for bread because bread's going to expand more than a typical batter would. So what I would recommend to you, use the number, to get started, use the number 2. So between 1.75 and 2.25. Let's just say we take the 94.2 divided by 2. This says we should put, ideally in this tin, 47 grams. I might go to 50, okay, but that gives you a benchmark. So in this case, we're planning on 2 cc's of volume per gram of raw batter, and this we're planning on 3.5 cc's of space per gram of dough. So we'll always have more expansion of our dough in bread, for instance, than we would have expansion of our batter in cake. And so by doing that, by knowing the cc's of space per gram of batter or dough, we have a better chance of managing the quality of our product and controlling our process and competing effectively in the marketplace.